Hello, today we are going to be learning about transformations of quadratic functions, okay? Transformations occur when we put other numbers with our x squared. So instead of just having y equals x squared, which we have here, we start having things like 2x squared or 3x squared or 5x plus 1. So we're always going to start with our, it's actually called our parent graph, the most basic x squared, the most basic quadratic is just y equals x squared. So in your note today, and while we learn transformations, you will be drawing y equals x squared a lot. So if you go over to your note and take a look, you can already fill this in on the graph. So like for all the graphs, you'll want to draw a y equals x squared. So basically you want to fill in the 5 major points. At -2, you have 4. At -1, squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. So those are the 5 key points of the parent quadratic. Okay, so you can fill them in the table of values under x squared everywhere, even on everything, on vertical translations, and you can just draw x squared. And same thing with horizontal translations. Now notice here there's more x values, but I'll get to that later. But you always start with just x squared. And usually I put that in a neutral color, either like a pencil or a black, and then show any other transformations with color. So you can start with that. I'm saving this last example for the end. But yeah, so just to kind of go over what happens. First, there can be a values. So a values are when you have something multiplying the x squared. So you can say right now that a is 1. So we just have 1x squared, which if I turn it on, it is the exact same thing. 1x squared is the same thing as x squared. But look what happens if that a value becomes larger than 1. So let's say I have an a value of 2. So I would like you to compare the blue parabola to the green parabola. So this is what we call a vertical stretch. So it's like you take the green parabola and you vertically stretch it upwards. And so that the blue one, 2x squared, is narrower than the original. What this means is that every y value is twice the height that it used to be, because after you square it, you're multiplying it by 2. So instead of 1, 1, you get 1, 2. Instead of 2, 4, you get 2, 8. Okay, so that's called a stretch by 2. So think about what will happen if I make a equal to 3. So if I make a equal to 3, the blue parabola gets even narrower because it gets stretched even further. So every y value is now multiplied by 3. So again, instead of 1, 1, you get 1, 3. Instead of 2, 4, you get 2, 12. All right, so now what happens if your a value is a fraction? So something between 0 and 1. Okay, so here's 1 again, back to just the parent. What's going to happen if I make a half, for example, or 0.5? Hard to get it exactly at 0.5 here. There we go. So notice now that the blue parabola is wider than our original green parabola. Okay, so this is called a vertical compression. So it's like you're taking it vertically and compressing it down to make it wider. So in this case, you square the x value and then multiply it by a half. So it makes sense that you're at half the height of the original. So instead of 1, 1, you're at 1 1/2. Instead of 2, 4, you're at 2, 2, etc. Okay, now what happens if a is negative? Well, you're going to be multiplying your y values by a negative number. So when you get 1, 1, what will happen if you multiply it then by a negative number? reflects. Okay, so a negative A value means that it's reflected across the x-axis. So we call this a vertical reflection. Because now first you square your x value, but then you multiply it by a negative number, which gives you a negative y value. So now it opens down and it looks like this. So this is where you just have -1, so it's the exact same shape, just reflected. Now, if you have -2, you get a reflection and a vertical stretch, right? So it's narrower by a factor of 2. So everything's twice as high as it should be, but then reflected. If you have -0.5, that is a vertical compression together with a reflection. So again, it's wider than the original, but what should I say? But also reflected. So if I press play, you can see how this can change. So it can get narrower, 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 facing up, and then go back, and then wider, 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 and then flip down and go narrow. So this is just for A values between 5 and -5. They can be anything you want. That's just to kind of show you how A affects the curve. So let's go and fill in our note there. So these are vertical stretches and compressions. So these are coefficients that are on the x squared term. So you're multiplying x squared, multiplying it by something. So again, I filled out the parent function for each. So if A is less than 0, the parabola is reflected on the x-axis. So these lines around A mean absolute value. So it just means the value of A, whether it's positive or negative. So if your A value is greater than 1, so like 2, 3, 4, 5, or -2, -3, -4, -5, that's a stretch. So it narrows, it gets narrower. And if your A value is between 0 and 1, then the graph is compressed, so it's wider. Okay, so let's take a look at how each of these affects our parent quadratic, okay? So we start with just looking at x squared. All right, but if we have 2x squared, what happens? Well, first we square our x value. So if you have -2, you get 4, but then you have to multiply it by 2. So you would get 8. Then you would square it. You would get your normal x squared and then multiply it by 2. Same thing here, same thing here, and same thing here. So notice that these are all 2 times bigger than the original. So that's how we get that wider look, because instead of 1, 1, we get 1, 2. And instead of 2, 4, we get 2, 8, and -2, 8. So it results in a vertical stretch by a factor of 2. Okay, so I do encourage you to use different colors on this note. So that is y equals 2x squared. So we say that this is a vertical stretch by a factor of 2. Okay, so now let's choose a different color for this. So here we have half. So this is a compression by a half. So we square our x value. So if -2 squared is 4, and then we multiply it by a half. So it becomes 2. This becomes a half, 0, a half, 2. Again, I'm just taking this x value and running it through this equation. This shows me what I would get if I put it through just x squared. This shows what happens after I apply the half. So every y value is half the height that it used to be. So that's what creates this wider parabola than the original. So we say that this is a vertical compression by a half. Okay, now let's take a look at what would happen What color do I want to do? We'll do light blue, I suppose. If we do it by negative 1.5. So we take our negative 2 and we square it. So we get 4, and then we multiply it by negative 1.5, we would get negative 6. Here we get negative 1.5, 0, negative 1.5, and negative 6. So two things have happened here. First of all, we have stretched by a factor of 1.5, and then we have reflected. Okay, so we can say that this is a vertical reflection, or you can say a reflection on the x-axis, and a vertical stretch by 1.5. All right, so that is how A affects the graph. Now we're going to look at vertical translations. So this is where you have a value that you just add. So after you have x squared, you add a value. So like x squared plus 3 or x squared minus 1. So if we go back to GeoGebra, we can see how this affects the parabola. So here's our normal x squared. So what happens? Notice here it says x squared plus k. So right now k is 0. So x squared plus 0. So it's the exact same parabola. But what happens if k goes up? All this is doing is taking that original parabola and moving it up or down. It's not getting narrower or wider. It's literally just taking it and moving it up or down. Now, if k is negative, it just moves down. So it's the exact same parabola. It's the same width. It just moves up or down. Bloop, 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 bloop. That's all that k does. All right, so if you have a k value that's greater than 0, it moves that many units up. If you have a k value less than 0, it moves that many units down. It's really that simple. Because this makes sense. You have your x squared, so you get your x squared value, and then you just add 3 to it. So 4 plus 3 is 7. 1 plus 3 is 4. 0 plus 3 is 3. 1 plus 3 is 4, and 4 plus 3 is 7. So you get this parabola. So it's the exact same shape. It's the exact same width, just moved up. That's it. So that's y equals x squared plus 3. And if you subtract 1, then you take your x squared values, which we already calculated, and then just subtract 1 from them. So 4 minus 1 is 3, 0, negative 1, 0, 3. So you get a parabola that looks like this. So again, the exact same width, if you draw properly, just moved down. So we say that this is a vertical translation, not transformation, translation down 1, and this was a vertical translation up 3. Okay, one last thing we're going to learn is horizontal translations. So this is to the left or to the right, okay? To the left, to the left. Okay, I won't make you do the Kids Bop Shuffle. Does anyone watch that? My kids watch Kids Bop. There's a Kids Bop Shuffle, it's a thing. Anyways, this is where you're adding or subtracting a number before you do the squared. So this is the weirdest one to understand. So notice that it says minus h, not plus h. And you might be confused as to why that is, but for now, let's just go with it. Basically, this shows us how much we're going to move to the left or to the right. So if I make h, let's say, equal to 4, Okay, so the equation looks like x minus 4 and then all squared. That actually moves it 4 to the right. So in this case, h is 4 because it's of the form x minus h. So if it's 4, then it's x minus 4. Everything just moves 4 to the right. If you have negative numbers, like negative 5, let's say, then that actually gives you x plus 5 because it's x minus 5, which is x plus 5, and that shifts the whole parabola to the left. Again, this doesn't change the shape, just the location. So let's take a look at this. So to graph x minus h all squared, translate the graph h units. So be careful, because if h is greater than 0, that actually means you have something like x minus 5, for example, all squared. So in this case, h is equal to 5, because notice that the general form has subtraction. If x is less than 0, it goes to the left. So that would be something like x minus negative 5, which would look like, all squared, which would look like x plus 5 squared. So if you see a plus there, in this case, h is actually equal to negative 5, which means you go left 5. So this will take some getting used to, guys. It will take some practice. So make sure you're really concentrating with these horizontal ones. So x minus 3, this actually means that h is equal to 3, positive 3. So everything's going to move 3 to the right. So you'll see why I have more x values in a moment. So let's see what happens here. So we take our negative 2, and these actually don't help us as much anymore. We take our negative 2, and we don't just add it to this 4, because this is what happens if we just square the negative 2. But because the brackets are here, we have to subtract the 3 before the squaring occurs. So negative 2 minus 3 is actually negative 5, and negative 5 squared is 25. Okay, negative 1 minus 3 is negative 4, and that squared is 16. 0 minus 3 is negative 9, is negative 3, squared is 9. 1 minus 3 is negative 2, squared is 4. 2 minus 3 is negative 1, squared is 1. 3 minus 3 is 0, squared is 0. 4 minus 3 is 1, squared is 1, and then this is 4. Okay, so I'm just taking these x values and putting them into this equation and seeing what y value comes out, making sure that I do the subtraction before I square. So negative 225 is too high to show, as is, I'm just going to see this 4, 1, 0, 4 pattern. So at 1, I have 4. Okay, at 2, I have 1, 3, 0, 4, 1, and 5, 4. Okay, and if you want, you can put in the 0, 9 as well. It's right there. And because of the symmetrical properties, that means there would be a 9 there as well. So notice that this parabola is the exact same shape, just translated 3 to the right. So this is a horizontal translation, right 3. Okay, now let's take a look at x plus 2. So in this case, h is equal to negative 2. Okay, so negative 5 plus 2. Negative 5 plus 2 is negative 3, and that squared is 9. Negative 4 plus 2 is negative 2, squared is 4. Negative 3 plus 2 is negative 1, squared is 1. Negative 2 plus 2 is 0, squared is 0. Negative 1 plus 2 is 1, squared is 1. 4, 9, 16. Okay, so see, here's the pattern here. The 4, 1, 0, 1, 4 happens at negative 4. And then here, I'm just plotting these points. Notice I was just kind of looking for that pattern that I'm used to. And here we go. So we have the exact same shape of a parabola. Again, this one's just moved to the left. So the table of values is just a tool to show you kind of why the translations occur as they do. So if you want to think about why subtracting a number moves it right and adding a number moves it left, you can. I'm not going to ask you that on a test. It's a bit more advanced. And to be honest, it's something that's kind of difficult to understand. So if you can do all of it, if you can figure that out, way to go. Okay, one last example where I put all three together. So basically you will have a parabola that is being stretched, moved to the right, and moved down. So three things happening to it. So the first thing I want to do is label what our A, I'm going to make this pink, what our A, K, and H values are. So A is the number that is multiplied on the outside. So our A value is equal to 2. Okay? Our K value is added or subtracted on the outside. So our K value is -4. And then our H value is what's inside here. But remember that it's normally X minus H. So H here is actually +3. So what does this mean? Well, A equals 2 means we're going to have a vertical stretch by a factor of 2. Then we are going to have a horizontal translation, right 3, and a vertical translation, down 4. And these are all changes on our original parabola. So first things first, let's draw our original parabola. So that's just 0, 0, 1, 1, -1, 1, 2, 4, and then -2, 4. Okay, I like to use symmetry like that and just draw it. Okay, so I am going to draw this in 2 stages. So you always apply A first. Always, always, always. If you want to think about it, it's the first letter of the alphabet. So my A is 2. So that means all of these Y values are stretched by 2, which means they're twice as high. So this one's at a 0, so twice 0 is still just 0. This height is 1, so doubling that gets me to 2. Same thing over here. This height is 4, so doubling that gets me to 8. Same thing over here. So here is the graph of 2x squared. So I've only applied the 2 so far. So now I'm going to apply my right 3 and down 4 in one step. So I'm going to take my new points on the pink curve and just move each one right 3 and down 4. And this one, go right 3, 1, 2, 3, down 4, 1, 2, 3, 4. Right 3, 1, 2, 3, down 4, 1, 2, 3, 4. Right 3, 1, 2, 3, down 4, 1, 2, 3, 4. Right 3, 1, 2, 3, down 4, 1, 2, 3, 4. So here is my final parabola. And you can label it with the whole equation. Okay, so it's been stretched by 2, and then each of those points after it's been stretched have just been translated right and down. Okay, guys, so that is your first look at transformations. Thanks for watching, and I hope you learned lots.